Done many integrals in this section involving sines and cosines. Well, what about the other trigonometric functions? So in this video and the next, we're going to take a look at integrals that involve tangents and secants. So the first one on our list to do is the integral of tangent x dx. This one actually is one that I think you've seen before. And if you remember this is something to be covered just from the substitution section. So we can rewrite tangent as tangent x is, of course, sine x over cosine x. And now this is actually tailor-made for substitution. How can we see that? If we let u is equal to cosine x, well then we see here du is equal to negative sine x dx. So that right there is negative du. So when we make this replacement, what do we end up with? After substitutions, minus sign outside, so just 1 over u du. So the integral of this is natural log of the absolute value of u. And we want to go ahead and replace u with cosine x, so that everything is in terms of x at the end of the problem. So here's the integral of tangent x. As I said, this is something that we've done before. It's also worth noting that sometimes this gets written slightly differently, that sometimes we move that minus sign up as an exponent. And so this ends up as cosine x to the minus 1 power. And cosine x to the minus 1 power is just 1 over cosine, and that's secant. So sometimes there's an alternative way to write this. Okay, so this is the integral of tangent x. In the next problem, let's just take a look at the integral of secant x. And as it turns out, this is a little bit more complicated to deal with. So we have to do a little trick here. And this is just one that I think going into it is obvious to do this trick. But what we're going to do is that we're going to multiply the integrand by something over something. We're going to multiply by secant x plus tangent x over secant x plus tangent x. So we're multiplying the top and the bottom by the same thing. So this is just this is just multiplying by 1. But as it turns out, this will allow us to integrate this. Again, we'll be able to use substitution. Okay, so why does this work? So our denominator, well, that's just still going to be secant x plus tangent x. And when we do secant x times this, we end up with secant squared x plus secant x tangent x. Okay, so take a moment here, see if you notice anything. And so the thing that you want to notice here is that secant x plus tangent x, so derivative of this, well, the derivative of secant x is secant x tangent x, and the derivative of tangent x is secant squared x. So this is all tailor-made for applying substitution here. So if u is equal to secant x plus tangent x, then du is secant x tangent x plus secant squared x, all of that dx. And that's right there. So we can go ahead and say this integral is the integral of 1 over u du. And so we end up with natural log of the absolute value of u. And of course, just as before, our final step is we need to substitute back in. And substituting back in gives us natural log of the absolute value of secant x plus tangent x, with a plus c at the end. So these two cases, the integrals of tangent x and secant x, they're kind of important special cases. These are just good derivations to know off the top of your head.